Next, as mentioned before, that sometimes we just want to know the rough idea of the size of the quantity that we are interested. So the process of the estimation or guess is useful. Sometimes we call it a guesstimation. It means that we guess or estimation. It is not the blind guess. We guess or we estimation the size using some principle, and we call the number that we get from our guesstimation here as the order of magnitude. The order of magnitude is a way to give you the rough idea of the size of the quantity, and the process of estimation of the order of magnitude follow these two steps. First, you express the number in scientific notation with the multiplier of the power of 10 between 1 and 10 and a unit. Second, if the multiplier is less than 3.16, which is the square root of 10, the order of magnitude of the number is the power of 10 in the scientific notation. If the multiplier is greater than 3.162, the order of magnitude is 1 larger than the power of 10 in the scientific notation. It means we plus 1 to the power of 10 in the scientific notation. For example, 0.0086 meter has an order of magnitude of -2 or 10 to the -2. 0.0021 meter has an order of magnitude of the 10 to the -3. Please note these two numbers. This one is larger than 3.162. Okay, so we give the order of magnitude. The larger here is mean that if you write down this in the scientific notation, it becomes 8.6 times 10 to the -3 meter. Okay, but the number 8.6 is larger than 3.16, so the order of magnitude becomes 10 to the -2. It is the -3 plus 1, right? But the second number is 2.1 times 10 to the -3, and 2.1 is less than 3.162. So we have the order of magnitude of the 10 to the -3. Now, for the 720 meter, it's 7.2 times 10 to the 2, but 7.2 is larger than 3.16, so we have the order of magnitude of 10 to the 3. Okay. So this is the process of estimating the order of magnitude of the quantity. Next, as the last topic in this chapter, this describes you the way to express your result in a scientific way. That is, the number that you express from your measurement or from your calculation must be meaningful. Okay, and we use the method of significant figure to express your number. Anyway, you will study this in more detail in the lab class, so I will not go deep in this course about the significant figure. I will give you just the rough idea of what the significant figure is, and it is used to express the measurement results, which is the leading, what you're actually reading plus one estimate digit. Okay. When you multiplying several quantity, the number of significant figure in the final answer is the same as the number of significant figure in the quantity, having the smallest number of significant figures. The same rule applies to division. Yes, that is for the multiplication and division. But when you want to add or subtract the number of decimal places in the result should equal to the smallest number of decimal places of any term in the sum or difference. Okay, so that is the basic principle of using significant figure. Go to the lab class to study in more detail. And for the last word, when you do the calculation, try to do it symbolic. Try to do the algebraic calculation as far as you can. Okay. When solving problems, it is very useful to perform the solution completely in algebraic form and wait until the very end to enter numerical value. Wait until the very end to enter numerical value into the final symbolic expression. Okay. This method will save many calculator keystrokes, especially if some quantities cancel. This is very important. When you do the calculation, sometimes you don't need to put the numerical value, some numerical value into your calculation, because at the end it will cancel. So that you never have to enter their value into your calculator. In addition, you will only need to round once, okay, on the final result. That will make your result more accurate. Okay, so that is the rule of thumb, that do the symbolic calculation as far as you can before put the numerical value in.